Gunner's car gets 22 and 4/10 miles per gallon, and his gas tank can hold 17 and 8200 gallons of gas. How many miles can Gunner travel if he uses all of the gas in his gas tank? Okay, so I know that I've got a car, right? Got some wheels here, and then how many gallons are in the car? 17 and 82 hundredths. Now, after I use 1 gallon, how far have I gone? What's my miles per gallon? Okay, so the first gallon of gas gets me 22 and 4/10 of the mile down the road. Do I still have gas left? Let's think critically about this. Look at my model. I only used 1 gallon. Gerardo says, yes, I do have gas. I've got about 16 and 82 hundredths of a gallon left. So this next gallon is going to get me how far? What's my miles per gallon?
44.
No, just this next gallon. How far do I go on my next gallon? Okay, and then the next gallon gets me how far?
22 and 14.
Then the next gallon gets me how far? Then the next gallon gets me how far? Are you guys going to make me do the 17 and 82 hundredths time?
No.
Didn't participate and actually say something. The next gallon is going to get me how far?
22.
The next gallon is going to get me how far? Okay, so the moral of my story is, at this point, I need to start making some decisions. Am I going to use the tools in my toolbox to make my life easier?
Yeah.
Am I going to add it 17 and something less than 1 times? Or do I have a different tool that I can use? Multiplication. Okay, thank goodness. Thank goodness for multiplication, because without it, we'd be adding our entire lives and never get to the end. So I'm going to write myself a multiplication problem. 22 and 4/10, and then 17 and 80. Now, we need to be a little bit strategic about this. It's always helpful to write the number with more digits. 1, 2, 3, 4. Write that on top. Because if I flipped it around the other way, then I would have 4 partial products instead of 3. I only want to have 3 because, math people are lazy. So here's my problem. I have to multiply 17 and 82 hundredths by 22. Anaya, what can I do to make this easier? What can I do to kind of just pretend like I don't have the decimals and do whole numbers? Okay, so I'm going to make myself some pretty little hoops. I'm going to go 1, 2, 3. So I know when I'm done, I just need to make sure I bounce it back in 3 bounces. And as an aside, all these 1, 2, 3 bounces just means that my real answer is going to be 1,000 times smaller than the answer I'm about to get. Don't stress about that. 1, 2, 3. Can everyone count 1, 2, 3?
Yeah.
Okay. So now I need to have 3 partial products because I have 1, 2, 3 digits. I always start with my smallest place value. And since I'm pretending that these are whole numbers, I'm now calling this my ones place. So what's 4 times 2?
8.
It is 8. And then what is 4 times 8? 32. Regroup my 3. 4 times 7 plus my 3. 31. Regroup my 3. Alex M, 4 times 1. Camilla, plus 3. 4 plus 3. 7. All right, so my ones place is done. Now I need to find my second partial product. let's look at the 2 in the tens place. To show that I'm in the tens place, what do I have to add, Alex V? Alex V? A 0. Why just 1 0? Yes, there's just 1 0 and 10. Beautiful. So now what is 2 times 2? It is 4. Thank you. I love the volunteers here. 2 times 8? 16. 16. Check yourselves. I'm going to regroup my 1. What is 2 times 7? 14 plus 1? Then I'm going to regroup my 1. What is 2 times 1? 2 plus my 1. Now I'm done with my ones place. I'm done with my tens place. Now what can I write? 2 zeros. Why? Because 100 has 2 zeros. I'm 1, 2 places over. Now, again, let's be strategic with this. Do I need to go back and actually do all the same math? Or did I just multiply I just multiplied by 2, didn't I?
Yeah.
So if I multiply the exact same number by 2, will my answer be any different? No. The only thing that's changed is the place value. So I'm going to have the same number right up there, just shifted one place to the right, technically, because it got bigger, right? So here I've got 1, 2, 3 partial products. I have 1, 2, 3 digits in my smallest factor. You have 1 partial product for every digit that you have inside your smallest factor. Now I just add up my 1s to my 1s, my 10s to my 10s, my 100s to my 100s, so on and so forth. 8 plus 0 plus 0. 2 10s plus 4 10s. 6 10s. 11. Regroup my 1. 1 plus 7 is 8. This is 8 plus 5, that's 13, plus 6, as Alex has been saying, 19. 1 plus 3 plus 5, 9, and then 3. Where? Here? It's a 0. Oh. Yes, that should be an 8. Thank you. Good catch. Monse gets points for busting me up. All right. So, as Monse said, that should be 8, and then we got 6, 1. Okay. So, did I have 1,782 times 224? No, I didn't. Remember my bounces. So, if I bounce it out 1, 2, 3 times, I'm going to start right here. Then I'm going to go 1, 2, 3. So that's my final answer. I pretended like I had a number 1,000 times as small, and I got a final product. Pardon me. I pretended as if it was 1,000 times larger. That's how I got rid of my decimal. But it wasn't 1,000 times larger than that. It was 1,000 times smaller. So I bounced back in 1, 2, 3 times. Guys, as long as the number matches up, you're going to be good to go. Okay? It's going to be very rare that you're asked, hey, exactly why does this work? They're pretty much going to ask you just, hey, what's the right answer? Most of the time, okay? So if you don't understand the whole 1,000 bigger, 1,000 smaller, chillax, count the ounces, and that's it. I'm going to do one more.